atoms energy band theory of crystals. Now we talk about gases. The atoms of gases are far apart from each other. They are so far apart that they have no influence on each other. But in crystals, the atoms are closely bound together. When they closely bound together, they tend to interact with each other and affect the energy field of the atom, and hence energy is modified. Okay, crystals. It consists of sparse array of atoms, molecules formed by regular repetition in three-dimensional system. In crystals, there is interaction of electrons between the atoms. Okay, but not all electrons participate in interaction. Only the electrons of higher orbitals participate in interaction. Why? Because electrons of higher orbitals have high energy compared to the inner orbitals. The inner orbitals are closely bound to the nucleus, hence they do not participate in interaction, or the interaction is very less compared to the higher orbitals. The interaction is less in case of inner orbit. Now let's see how energy band is formed. Okay, the x-axis here denotes interatomic spaces and y-axis here denotes energy band. Okay, the p and s here are orbitals. I hope you are familiar with sp-df orbitals. Okay, 2n electrons in 6n states in p orbital, 2n electrons in 2n states in s orbital. Now why are we saying 2? What does 2 here signify? We know that electrons spin in two direction, right? They have integral spin in two direction. One is half positive half and negative half. That is why here 2 is used. Okay, now if we take the first condition, that is d1, that the interatomic spacing is quite large. In the first case, at that time the electrons are in their respective states, in their respective orbitals. Okay, but what would happen if they are brought close to each other, or they come close to form molecules? Let's talk about it. When atoms are far apart, it has valence atomic orbitals p and s which have same energy at d1. Okay, but if interatomic space is decreased progressively, then atom exerts a force on its neighbor. We have talked about it. It interacts with its neighbor. When the atoms come close together to form molecules, their orbitals begin to overlap. Now let's take two atoms here for simplicity. If they come close to each other, they will practically overlap each other. Okay, now at this point electrons can have same quantum number, or they tend to have same quantum number. But is this possible? No, because according to Pauli's exclusion principle, no two electrons can have same quantum number. So what happens in this case? The two orbitals split to form, sorry, the overlapped orbitals split to form two molecular orbitals. Why two molecular orbitals? We have taken two atoms. If we are taking, or we are talking about n atoms, then it will split into n molecular orbitals. Okay, due to Pauli's exclusion principle, their atomic orbitals split to form n molecular orbitals of different energy. Now we know that in a crystal, number of atoms is in the range of 10 raised to power 23. Now this value is quite large. Okay, when we have so many molecular orbitals, and also they are close to each other, right? Because in crystal atoms are closely packed, so 10 raised to power 23 molecular orbitals are close to each other, hence they kind of forms a continuous band. Since n is such a large number, and also as adjacent orbitals are close together, orbitals can be considered continuous energy band. Here we are getting two bands, conduction band and valence band. We will talk about this in detail in our coming lectures. Okay, hence the orbitals, atomic orbitals split to form molecular orbitals which are large in number, which forms conduction band and valence band. This is how bands are created.